Hope it's on. Now we're gonna get in trouble. Alright, Chapter 5, Lesson 2. Theoretical and experimental probability. Let me give you a minute to write this down, and then we'll get started. Let's play with this ribbon while we wait. Alright. Percentage question hadn't changed. How do we use probability to predict the future? The two things we're looking at today are theoretical and experimental probability. Experimental is what we did today, or yesterday, in lesson 1. Is just what should happen in a perfect world, what the outcome should be. And then experimental probability, this is the part that's new. This is what actually happens if we bothered to test whatever our event is. So what we're going to do, instead of doing examples from the book, because that was boring and had a lot of words, we're just going to perform an experiment. And by we, I mean me. Okay? What we have here, we have a spinner. It's got 4 colors, blue, green, red, and yellow. You can copy this part down so you can see it. Doesn't have to be too big. Okay? 4 equal parts. And then we're going to start with what's the theoretical probability and what is the experimental probability of our 4 different sections. Okay? Give you a second to copy stuff down. Alright. So theoretically, since all 4 of our sections are the exact same size, should be an equal chance of landing on any of those 4. The probability of any color specifically should be 1/4. 1 out of 4, 1 out of 4, 1 out of 4. And all of these, so we can compare them later, are 25%. And in a perfect world, that's what should happen. And then what we're going to test is whether or not that's true. And hopefully the answer is no. Then we can talk about why. So what I'm going to do, I'm going to say, let's do 20 trials. I'm going to spin the wheel 20 times, and then I'm going to record what I get. Alright, here we go. Maybe not. Oh, this is going to be hard. Okay, so I spin the wheel. And I got red. I mark down, tally mark for red. Okay, and I spin it again. Okay, this time I got green. And we spin it again. We're just going to do this 20 times. Red. Should have thought of a better way to do this. Okay, now blue. You can make your own spinner and try this out. Green. And then red again. Ooh, red again. What's that? That's 7. So excited. Then blue again. We just put a tally mark every time our trial comes by. Blue again. And then green. It's working out just right. Oh, no yellows yet. Another red. That's 5, 8, 11. Okay, 9 more. One more for blue. Hey, yellow's on the board. Right, then blue again. And then green. And red. Probably skip through this. Not sure why you're watching me spin this 20 times, but I appreciate it. What's that? That's 15, 16, 18, 2 more. Then blue. And last one. Yellow. Alright. Then our frequency is our total. We'll put total up here in case you've never seen the word frequency before. We landed on blue 6 times. On green 5 times. Red was 6. And yellow was 3. And that does add up to 20. Okay, good. So if we take our experiment's probability, we're going to say how many times did it happen. So blue was 6 out of 20. Okay, and then we can simplify that. That is 3 out of 10, which is 30%. Okay, green was 5 out of 20, which is 1/4, and that is 25. That. Red was the same as blue, so 6 out of 20, or 3 out of 10, or 30%. And then yellow was 3 out of 20. Oops. 20, not 30. Again. Can't simplify 3 out of 20. That's just going to be 15%. And now we can compare these two. So how did our theoretical probability and our experimental probability, how do they match up? So we could say anything that had a higher percent here, so like blue and red, let's say blue landed more frequently than expected. We can say, send this out, that yellow, because yellow is supposed to be 25% of the time, was only 15%. So yellow landed less frequently than expected. And green was just right. Okay, there's our results. The difference between theoretical and experimental. So sometimes they work out the same, which is nice, but not necessary. Then it's going to ask you, why is it these numbers are not all the same as that? And we can say, if experimental, and is this going to ask you, like, why are they not the same? So we say, if experimental is not the same as theoretical, then we need more trials. And that can be your go-to answer. But why are they not the same? Because we just didn't try it enough, right? Like if you remember, like when we first started, it took us like 10 spins before we got one yellow. So if we had stopped there, we'd say there's a 0% chance of it landing on yellow, but we know that's not actually true. It was just unlucky. So we can get rid of the luck factor just by performing more trials. Okay? And that's the whole idea here. So one last thing we can do. We can expand on this. Like let's say this is the truth, right? This is how it's always going to be. It's going to land on blue 30% of the time. So if it lands on blue, 3 out of 10. So if the probability of blue is 30%, or 3 out of 10. So what if we spun it, I don't know, 200 times? So how many times would we affect the spinner if we spin it 200 times? Question. Okay? Oh, one comment. Leaves. Alright, thanks for the leaves. For leaving me a comment. Alright, it's 2 ways we can do this. Both ways start out with 3/10. We could either take the probability and multiply it by the number of trials. So 300, or no, I'm sorry, 3 over 10 times 200. Okay. So if we did this math, this would be 200 over 1. And then we multiply straight across. So 3 times 200 is 600. 10 times 1 is 10. And then if we simplify this, or we divide 600 divided by 10 is 60. This is the homework for Mrs. Price. These are the notes. So we would expect 60 blues. Alright. Now the other way we can do this, because it's 7th grade, and we said everything in 7th grade comes down to proportions, so why can't this be proportions? If we say part to whole, in this case our part is blue, and the whole represents total, we say blue should show up 3 out of every 10 times. And then on the other side, this is the actual result, and we said that this should be 200 total rolls, how many of which should be blue. And then if we look at this math, blow your mind here, if we solve this portion, if we cross multiply 3 times 200, that's what we did here, and then we divide that by 10, which is what we did here, and we get 60 blues. How neat is that? So anytime you want to expand your trial, instead of actually doing it, that takes too much time, You can either multiply your base probability by how many trials you want to do, or you can write a proportion with your probability on one side and the number of trials on the bottom. My Thanksgiving was wonderful. Okay? Either way, we'll give you an answer, and then that's about it. So what you can do with all this space here, what if you made your own experiment? So go, oops, I don't know why that's an E. Backspace. So what if you find yourself a coin? Okay. And you say, theoretically, what is the probability of landing on heads? What is the probability of landing on tails? And you should be able to figure that out. That's not too hard. And then you're going to make yourself a chart. Okay, so you say land. You get heads, tails. Give yourself some space here. Alley. Frequency. And let's say, what's a good number? I'll let you figure out a good number. So blank number of trials. So you're going to flip the coin some number of times. I was thinking like 30. Maybe 20. 30 might be a bit much. You want an even number. So ideally, you could potentially get the same for both. Right? And then we figure out what is the experimental probability. For heads and tails. And see what happens. And then show it to your math teacher. Okay? Alright, that's about it. Okay. Good night. Hit Eric. What up, Eric? What up? Math's up. What lesson is this? This is chapter 5, lesson 2. Experimental theoretical probability. Okay. You're welcome. Chesse steak. Feel like that was supposed to say cheesesteak, but then you spelled both parts of your name wrong. That's unfortunate. Or is it ironic? I don't know what the kids go for these days. Yup. Yup to which part? Horrible mistake? Totally on purpose. Let's see what's on Chesse Steak's channel. The Haunted Fort. Interesting. The Deal. I don't know if I want to look at this. It's gonna be adult appropriate. I spell wrong on everything else I use this name on. Interesting. Do I want to watch these videos that you made? Or am I gonna be upset? You just deleted them, but I'm watching it right now. Stop. Alright, I'll stop. I wanted to see where it was going. Alright, it's been 20 minutes. So I'm out.